Okay, so this is what that software that will be we will be using at the initial stage, just to understand how the hub functions and how the switch functions,
Mm-hmm.
and what is the difference between these devices and why we need switch, not the hub.
Mm-hmm.
So okay, let me just tell what is this software first of all. This is a Cisco Packet Tracer.
Mm-hmm.
It is said to be it is simulator. Simulator means it is something like which how to say that imitate the real device, but it does not the it won't function like a real device, right?
Okay.
So that is what it just simulates. It does not give the full functionality of that router or the
Okay.
switch. So
Okay.
there is the software something like GNS3 or
Mm-hmm.
EVE-NG.
Mm-hmm.
So let me show you quickly that as well. So this is a GNS3. Okay, these are called
Mm-hmm.
emulators, not
Mm-hmm.
simulators. Why? Because actually we will be uploading the real the image of the router or Cisco
Okay.
in GNS3. How we are loading the operating system to the laptop or desktop, something
Okay.
like that. Okay, we
Okay.
will be loading and we can start using that. So it will it functions are as real as the original device.
Okay.
Okay, so since but these emulators cannot do switching as the real switch does. It only performs the routing with a 100% efficient. But
Okay.
switching it is not possible through GNS3 or even G. We have the images with some limitation. Few things are
Okay.
not possible. I can share you
Okay.
that link, Abdul. I'll give you a link so that you can just share it with John.
Okay, okay, you
Okay.
can send me. I will share.
Okay, sure. So let me pull this up. You can see here, right, at the top, bottom and near to the start icon.
Mm-hmm.
Here I have different iconic symbols. One is routers. One
Mm-hmm.
is if you just move over it, it will give you what is that switch and hub. Wireless device, security, which is a firewall, which is a WAN emulation, and this is again. These are a subcategory of this network
Okay.
devices. And
Okay.
if you click on that end devices, see network devices and devices. These two are
Okay.
two different category. How like we have studied network access device, network infrastructure device. They are again
Okay.
different. They everything come under this category, and these are
Okay.
come under different categories and devices. So
Okay.
as of now, we don't want to know about all these things. They are part of different uh, you know uh, different category of the certification.
Category.
Yeah,
Okay.
so this mention what type of cable that we are going to use. Okay,
Okay.
this is like automatically choose a connection based on the connecting to different end devices.
Okay.
End devices means two nodes. Okay, if you're connecting
Okay.
router to router, what type of cable? If you're connecting router to switch, what type of cable? That
Okay.
automatically it detects based on that. And
Okay.
this is blue one is a console cable,
Mm-hmm.
and thick black cable is a straight through cable. Okay,
Okay.
you can see the name here, it just reflects.
Oh,
And the
okay.
dotted cable is a crossover cable,
Mm-hmm.
and orange one is a fiber cable.
Mm-hmm.
And actually this is for telephone, and this for
Mm-hmm.
coaxial.
Mm-hmm.
These two we won't use. And there are two things. One is serial cable with DCE and connection, and
Mm-hmm.
serial cable with DTE type. And there
Mm-hmm.
are three more cables. We don't want to worry about that. Only we need to worry about this straight through or crossover or
Mm-hmm.
serial cable.
Mm-hmm.
Okay. Let me take a hub here. Okay. So also let me take a few end devices. If you click here and if
Mm-hmm.
you put it here, only once you can
Mm-hmm.
use PC. So while clicking also, if you press the control here,
Mm-hmm.
Okay, you can use multiple PCs as like you want.
Okay.
Okay, and in this case, I want to connect a hub and PC, right? A hub
Mm-hmm.
is a layer one device, right? So how
Okay.
about so if I want to connect these PCs with this hub, what type of cable I need to use is these two are not from a actually we have studied hub is a layer 1 device, switch is a layer 2 device, and router is a layer 3 device based on their functionalities. So if I want to
Okay.
connect a PC to hub or switch, then I need to use straight through cable, okay,
Okay.
not the crossover one.
And
Crossover is when you're connecting the same layer devices, right? Hub to hub or switch to switch or router to router, something like that. So
okay.
what you can do in this case, just I'm clicking on this straight through cable,
Mm-hmm.
okay, and click on that PC now.
Mm-hmm.
What are the ports that is available with the PC? USB, RS-232, fast Ethernet. Let it is Ethernet cable, so I'm connecting it on the fast Ethernet port
Mm-hmm.
and taking towards to the hub fast Ethernet port 0.
Mm-hmm.
So in this case, actually, there are many ports associated with the hub, and
Mm-hmm.
again there are multiple ports associated with the PC, but it is just showing me the link, not the interface ID, which interface that I have connected. So to
Okay.
enable that option, just go to options, preference, and there is something called always show port labels in logical workspace.
Okay.
This is disabled by default. You need to
Okay.
enable it, okay, so that you can see, okay, it is connected to fast Ethernet 0 and here fast
Zero.
Ethernet
Okay.
0. Okay, I don't want to do it okay each time okay you while practicing you can do it, it does
Mm-hmm.
not make any harm, just again by clicking on control, then clicking
Mm-hmm.
on this wire,
Mm-hmm.
you can just do that. Or also you can again click on control button, then click on this thunder one,
Mm-hmm.
uh, and just you don't want to select any port,
Mm-hmm.
automatically it choose which port it need to take. See,
Oh, okay.
I'm not choosing any ports,
Okay.
right? Okay, let
So
me just
zero, zero, one, two, and three.
right. Just for understanding purpose, let me okay. The port IDs are clear now, right? Okay.
Mm-hmm.
So without IP addresses, without MAC addresses, we
Mm-hmm.
cannot communicate over the network. This is what we have
Okay.
learned.
Okay.
So, what is the IP address? We will be learning before going to the routing. But since
Mm-hmm.
for switch, now we are into switching at the basic at the foundation level. So here you don't want to
Mm-hmm.
worry about IP addresses. So for simple, what I'll keep 192.168.0.1. Okay, and if you just click on the subnet mask, automatically it populates some value.
Okay.
Okay, so you don't want to worry about this. Just make sure that you use the same IP schema. You'll be understanding what is this IP, why we are using in IP addressing and subnetting section.
Mm.
Okay.
Is this automatic as dynamic host control protocol (DHCP)?
No, no, no,
Oh,
no, I am under the
this is
static.
static.
See, yeah,
Static. Okay. But
yes.
so even static, it will still give you the subnet mask.
Yeah,
Automatic, or
subnet
you have to
mask.
type
It
in.
is a mandatory one actually. Actually,
Yeah, but
uh,
what I
yeah.
mean is,
Mm-hmm.
under the dynamic host control protocol,
Mm-hmm.
normally it's supposed to do automatic. Yes, it will
Exactly.
find the IP. But
Right.
on static,
Mhm.
normally you told me you have to manually type it in. But
Right.
in
Right.
this case, when you click on the subnet max, the
Yes.
subnet
Automatically
max come
populates.
automatically populates.
Okay. Why?
So why you didn't type it?
Because yeah. Why? Because this 190 to 168 is part of class C address type. We can say. Okay. So
Okay,
there are
okay,
different classes: class A, class B, class C. So for
yeah,
class A, the subnet mask looks like 255.000. For
000.
class
Okay.
B, it looks like 255.255.000.
Mm-hmm.
And for class C, it is 255, 255, 255.0. So
Okay.
this is based on the classes. Okay, just I'll
Classes.
remove.
Okay.
Yeah, just I'll remove this subnet mask and let me
Mhm,
type some other address from 10.0.0.1. So I
mhm,
told like for class A it should be 255.0.0.0, right?
mhm,
Let me
mhm.
just come click on this. You see this.
Okay. All right.
Okay, so this is automatically generated by the CPU based on the IP addresses,
IP
the
addresses.
ranges what we use actually.
Okay.
Okay, so don't change anything on the subnet mask and just
Mhm.
use these IPs by keep incrementing on every PC. Okay,
Okay.
go to a desktop IP configuration, and I have used 10.0.0.1. If I go to
Mhm.
subnet mask, it gives you an error. This address is already used in the network.
Is already used.
So
Okay. So
yeah, so
10.2.
there can be one John. There cannot be multiple John
Multiple
in this
joins. So
node.
you
Okay.
10.2. Yes.
Yes, right.
Mm, okay.
Okay. The same way in this PC
And
again, desktop
10.3.
10.3, and here it
10.4.
is 10.4. Okay, now we are good. There is no confliction in the IP. Here, if you notice, there are two modes. One is the real-time mode, one is the simulation mode, right?
Okay.
Basically, this hub, what we call the hub in the other name is actually a multi-port repeaters.
Okay.
Okay. So what actually a repeater is? You remember? We have discussed that during our
Mm,
OSA layer.
mhm,
Basically, a repeater, what it does, it boosts the signal so that the signal can travel. Okay, let's say that this is an Ethernet cable, which is which has a standard. Okay, it cannot exceed more than 100 meters.
mhm,
Okay, and why? Because they have the cable, large bundle of cable.
mhm.
They can even have 10,000 meter as well, but they won't do. Why? Because the voltage pulses which is traveling inside the copper of the cable, which
Mhm.
have the capacity of traveling only this distance,
Okay.
right? So if you have two nodes which are 100 meter or less than 100 meter far away, it is fair enough to use one single cable at one
Mhm.
stretch. What if
Straight
they
through.
are far away from 200 meter or 250 meters? So we need something called a
Repeater
repeater. What
to
it does,
extend
yes,
this signal. Mm.
yes, it boosts the signal at this endpoint when it receives here, so that data
And travel.
whatever, yeah, for another certain number of kilometers,
Mhm.
sorry, meters.
Yeah.
Okay, so this is why the repeater, what this is what the repeater does in general. When we call as a repeater, it has only two ports. One is for incoming, one is for outgoing.
Outgoing. Okay.
Okay, there is no other port for any other purposes.
Okay.
Basically, the same job hub does,
Mhm.
but it can have at minimum four ports.
Okay.
Okay,
Just like just like switches now, they have
yes,
four ports
yes.
and all that.
But at max, it can have eight ports. Okay,
Okay.
but in hub, what it happens is, okay. Let's say that in each port, I have connected the end host, which is my PC or laptop, whatever it is. If I
Mhm.
send okay, this is A and this is
Mhm.
B and this is
Mhm.
C and this is D.
Mhm.
If I send some data from A to B,
Mhm.
this what happens is, in this port, this particular data will be copied three times and it will be broadcasted to
Mhm.
everybody.
Across everybody, so everybody can
Yes.
see
Yep.
your stuff basically.
Yes. So,
Mhm.
do you remember something we have discussed about topologies, like
Yeah, you
ring,
said
bus, star?
yeah, ring, bus, star, yeah,
Yeah. So, in that case,
physical and non-physical.
exactly, logical. So, in
Yeah.
that case, what behavior is this? See, we have something a centralized box, like not a bus cable, right? But the data is like going to everyone, not to just one destination.
Single, yeah.
Yeah, right. But it is supposed
Mhm.
to be, I have sent only to B, not to C or D. But Hub is
D,
not that intelligent to identify
yeah.
who is B,
S-
who is
And
C,
who
and
is
who is
C, who is
D.
D? So we
Yeah,
send to everybody.
yeah, exactly. So physically, it looks like star topology,
Mm-hmm.
but logically, it looks like a ring topology.
Ring topology, yeah.
Why?
Okay,
Why
so
it is looking like star topology? We are connecting the two end hosts
mo-
separate, but the function wise, if you see, they are not working like a star. If I install
no,
from A, it should go only to B, not to C or
to
D.
B, yes, not to C or D, yeah.
Yes, but this is what happened in Hub. Okay,
Yes.
so
But
how you
ring
can?
ring topology, it will copy it, but it will send it across.
Yes, exactly. That is a
Mhm.
token ring or FIDI.
Yes, yes.
So how we can prove that whether it is going to function the same way? So to see that, we need to switch from real time to the simulation mode. You need to just click
Okay,
here. Okay,
okay.
and where is it? So here, these are called PDUs. Okay, simple
Mm-hmm.
protocol data unit. Actually, PDU means what? A data which is given name for different layers when it get processed, right?
Okay.
Let's say that now I'm sending a message from this PC to
Mm-hmm.
this PC, right?
Mm-hmm.
See here, there is something got popped up here.
Mm-hmm.
ICMPR, don't worry about it. I'll let you know what it is shortly once
Mm-hmm.
we get into switch.
Mm-hmm.
Okay, what had happens here is, let me just play. See, the data is now at
Mm-hmm.
hub.
Mm-hmm.
Okay, let me again see, it is getting broadcasted to everyone.
Everybody, yeah.
Okay, let me resume here. Sorry, let me pause here. But see here, this data is getting discarded at these two PCs,
Yes.
but it
This
received the
one
data.
received.
Yeah.
Received, yeah. Mm-hmm.
So once he received the data, what he does, he'll be replying back to
Back
the
acknowledgement, yeah.
acknowledge back to that sender. In that
Yes.
case, also, what happens? Hub will just broadcast to everyone.
Everyone, yeah.
Let me resume that. We can see that. See. So
Yes.
here we can notice our communication successful that he got the
Yeah,
acknowledgement.
successful. He got it back, yes.
Yes, but here it is showing
It's not for
red
it's not for
indication.
them. So yeah, it's not for them. So they discard it.
Exactly. So basically, what it has inside, let's just go and see. Just click on this type payload. Okay, it will open something like this. It is at which device? It is at PC0, right? You can
Uh-huh.
see in that event list. At device is PC0. So
Okay.
in PC0, you can see there are 7 layers in OSI
So which one did you click to get this one?
here.
Oh, okay, there. The type.
Okay.
Okay.
Yes,
Okay.
let me
All
close
right.
this. If you type here, it will
Okay.
pop up.
On top of it. Okay.
Okay.
Right.
So it is going out of this PC. So it is
PC
there at
zero
the
to
out
PC.
layers.
Yes. So
Okay.
from PC zero to PC three. Yes.
Yeah, exactly right. But see here, what we have, IP header, source IP is what? 10.0.0.1
There's a one
and
destination.
10.0.0.4, right? If you remember
Mm-hmm.
the IP what we have
Mm-hmm.
assigned.
Mm-hmm.
Okay. So let me just close this. And what is this? Again, it is at PC0 only.
Yeah.
And, but it is not ICMP. It is something telling me like ARP, which is Address Resolution Protocol. See
Mm-hmm.
here, it came to layer 2 now. Before it was layer 3,
Three. Yeah.
right? In layer 2, actually, what it have is the source MAC address and then the destination MAC address.
FFF. Yeah.
Okay, so what is FFF? FFF is something like a broadcast frame you can think, or broadcast layer to address. Okay.
Okay.
Okay, that means I'm Durai and I know John, which is like IP address. John is IP address, but I don't know where John resides. I don't know the
Okay.
address of the John. So address is something like the MAC address. I only
Okay.
know the IP address. Okay,
Yes.
how I can find the address of the John? That means the MAC address of the destination is
Yes.
through using the ARP protocol. Okay,
Okay.
ARP is a protocol who is helping us to resolve the layer 2 address using the layer 3 address. What is layer
Okay.
3? IP address. What is layer
Okay.
2? MAC address.
MAC address.
Uh,
Okay. So
so
address request protocol is gonna ask for from layer 3 the IP address. Yes.
yes, exactly.
Mm.
It is going to
Okay.
get the
The
MAC
IP
address.
address. Yeah,
No,
MAC
no,
address from layer
MAC
2.
address.
Yes.
Using that IP address, it is going to get that MAC address.
MAC address from layer 2. Okay.
Right. So in our previous session, actually we have studied something like usually the payload contents like destination IP and then source IP,
Source
then
IP. Yeah.
destination MAC, and
MAC.
then
So
source MAC,
MAC address. Yeah.
and then data, right?
Data. Yeah.
In this case, actually, we will be filling up with something like AAA,
Yeah.
BBB.
Yeah.
So when that receiver receives, it checks actually that particular MAC address. If it passes, then only it will check the IP address.
Mm-hmm.
In this case, FFF, it is, I have told you, it is a broadcast MAC address.
Okay.
Okay. So what happens when PC receives? Maybe its destination, its MAC address is different. How we can confirm is just place your cursor here.
Mouse. Mm-hmm.
You can see, right, the fast Ethernet MAC address is something different, 0030.
Yeah. 30A8347. Yeah.
Its MAC address is 000.
0B
Yeah, its MAC address is 000C.
C. Yeah.
How we have studied, it should not supposed to take this packet. It should drop it. Why? Because it is not
Yes.
F. But technically speaking, I have told FFF is a broadcast frame,
Mm-hmm.
so there is still understanding at the end host. If there is no unicast MAC address, which is not mine exactly matching, otherwise, if there is a broadcast MAC address, either one of this is present, I'm good to forward the data to the layer 3.
Okay.
Okay, either it should have the exact unicast MAC address or it should have the broadcast MAC address. That
Which
means
is which is uh which is
FFFF.
FFF. Which okay. Which is the default, like you explained last time. If you don't put it, then it will generate its own default one. Yes,
Yes,
FFF.
yes, yes.
Yeah.
Okay. So in that case, it will accept the layer 2 payload, then it will check the layer 3, which is the packet, IP packet. Then it understood the packet is actually, you can see here, right? Destination IP address 10004. So it is
Four.
for
Yeah.
him so that he can receive it. Okay.
Mm.
So what happens here? How the ARP is exactly working? So let me just remove everything. So let's say that this is my switch. Okay, for time being, let's assume that it has AAA and
Mhm.
BBBB and CCCC. So here, this guy have the IP address 10001
Mhm.
with the subnet mask /8, which is 255,000. That can be
Mhm.
also represented by in this fashion /8. Don't worry, we are going to cover it shortly. might be in next class.
Mm-hmm.
Okay, so it is 3008. They are part of same subnet. That is what it mean actually. Okay.
Okay.
Uh, in this case, I know 10003. There is a guy, but I don't know what is his MAC address. So what I am
Mhm.
going to do before actually sending my data, first I will try to find what is this guy's MAC address.
MAC address. So it's
Okay,
the
how
then for
I'll
sender. It will use the
yes,
app. You will use the app.
yes. So
Mm.
what ARP is going to do? ARP is going
On a
to
request.
request. So who is initiating the ARP? That is the main one, either hub or the PC. Who doesn't know the MAC address?
The PC.
PCA it doesn't know the MAC address. Okay, it
Yes.
is nothing with the hub who will
Because
do all this checks.
hub is not intelligent enough. Switch is
Exactly.
intelligent enough, man. Mm.
Yes. Right. So in this ARP, actually, what it happens. Actually, in the payload, instead of putting the destination MAC address as CCC, I'm going to put the destination MAC address as FFF. Right.
As
So
default.
that
Yeah.
yeah, BB. So the second PC does not. He'll when it goes to this
It will
guy,
discard it. It will discard it. Yeah.
no, he'll not discard it. At layer 2, he'll pass it. At layer 3, he will
Okay.
discard it.
It will discard it. Yes. Okay.
Okay. So when it go to PC 3, at layer 2, it will pass. But at layer 3, when checking the IP, sorry, okay, it will pass again.
Okay.
Right. So now what
Yes.
this guy do? This guy will be replying back. Okay. Now the destination IP address, it will be 10.0.0.1, and the
Mm-hmm.
source IP address it will be 10.0.0.3,
Three.
and
Mm-hmm.
destination MAC address would be AAA.
A. Mm-hmm.
Source MAC address will be
C C C
CCC,
C C. Okay.
and after that acknowledge data.
And data.
Okay.
Yeah. Mhm.
When this goes, again it will be flooded to everybody.
Everybody. Yeah.
Right. This guy at layer 2, what happens at layer 2? What this guy does? Layer 2.
Layer two. It will discard that one.
Exactly. Why? Because it is sorry, it is
This
AAA.
A. Yeah.
Right. So what this guy do? At layer 2 also it pass. At layer 3 also it pass. And also
Pass. Yeah.
what he got it? He got the MAC address of the
CCC.
yeah. This is how actually is getting the MAC address of that receiver. Okay.
Yes.
Once he got the MAC address through our process, now
Yes.
he'll use that MAC address to send the actual data.
Data.
Until unless the ARP is not completed, the actual data will not be flown from source to receiver.
Receiver. Other
Okay,
than that, it will use the default FFF.
exactly. See here, when I'm trying to send ICMP data, ICMP is a protocol, the
Mm-hmm.
data based on the ICMP protocol, but this PC doesn't know what is the MAC address of this MAC destination. It
PC4. Yeah.
automatically started with the ARP
With ARP.
protocol.
Right.
Yes, right?
But if we could get the what you call it MAC address, then you would have used ICMP. Yes.
Yes, right.
Mm.
So once, see here, where is it? At PC2. Okay. Fine. So we can go by layer. So here we are at hub 0. In hub 0, there are two layers. One is the incoming layer, right? Actually,
Mm-hmm.
the data is incoming on fast ethernet 0, right? At
So
layer 1.
fast internet zero is
Yeah.
at layer one,
Yes.
incoming, and then
Yes.
outgoing is fast internet three. Yes,
No, one, two,
to
three.
PC4.
One, two, three.
Oh, okay. So
In the
three outgoings.
yeah, in the perspective of hub, right? It is not routed
Okay,
or it is not switch.
okay.
So let's go here at PC1. What is happening at PC1? See the layer 2 address,
Mm-hmm.
right? We can see from where it has come, and it is through the incoming layers, and what is the destination
MAC address.
MAC address and everything.
Source
and
port, destination
so
port. Yeah.
yeah, so that's it. It will just it will ignore after that, and again the same thing happening for PC2
PC2.
and
Okay. But then
PC3.
PC2.
Yeah, since it is how we can confirm is whether it is ticking or not. Only the accepted data we can see here, not that discarded data. So after that, I am not having any data at layer 3, so there is no data that I can consider. But if you see the PC3, there is a incoming layers and also there is a outgoing layers. Is actually responding back, right?
At
See
layer
here,
2
yes, at layer 2, the FFFF is being replaced
with
with
000.
C, 000
Yes.
C,
C
because
as MAC
the
address.
destination becomes the source when he is replying back,
Source. Yes. Yes.
right? So when it reaches the hub, again there is one incoming layer, three outgoing layer, and the same thing at PC0. There is only the incoming layer. He is not going to acknowledge back
Out.
anything. That's
Yes.
it. You can see the MAC address that he got it, zero zero
Right.
zero C. So this is fine. Okay, how long this MAC address be kept? How long the PC0 know the MAC address of the PC3, right? Yeah, PC3. Okay, so that will be answered by this table called ARP-A. All this MAC address, whatever it learned dynamically, right,
Mm-hmm.
will be stored
Sure.
under this cache memory, ARP cache
Okay.
memory.
Okay.
Okay, so even though the PC 0 know the PC3 MAC address,
Mm-hmm.
Hub is not going to stop broadcasting to everyone. It's just going to broadcast anytime. It will not
Anytime.
unicast, right?
Yes.
So,
Yes.
but this art will not be seen hereafter when the communication is happening from PC0 to PC3. Why? Because he already know what is the MAC address of
MAC
this IP
address
address.
of IP
Okay.
address. But
Yes.
on
So
dynamic,
yeah.
on dynamic,
Mm,
when I was watching one YouTube on dynamic, the IP address,
mm.
not the MAC address, the IP address,
Okay.
because it's on dynamic,
Okay.
is only leased for a short period at a time. It's
Basically,
gonna change, isn't it?
yes, it is going to change once you shut down. And if you are talking about the DHCP protocol,
Yeah.
right, the IP address, it is going to get it dynamically. So it is not
Yeah.
the fixed one.
Yeah.
Whenever you switch off and switch on, there is no guarantee that you'll get the same IP
The
address.
same IP address. Okay.
Yes. So what happens? Let me just see. It is a new version. There is a left arrow, right? Just click on
Uh-huh.
that. Will
Yes.
to the progress. See here, once the art is received, when the MAC address is received,
Uh-huh.
right? Not yet successful. The communication is still in progress.
In
Only
progress, yes.
got it, but actual ICMP data I have not yet sent. But here I'm just trying to send it with the proper destination MAC
MAC
address.
address,
But if you
yes.
see here, there is I don't know about. Sorry, it is here. I don't know about the
Yeah.
destination MAC address. It is FFF.
Right, right.
Okay, let me just play this again. So now you can see the actual data, the ICMP data is being flowing front and
It's
back.
been flowing. Okay.
Okay, and you will see the progress is successful or failed.
Successful.
All right.
Okay. So
So
that means it's sent and it's received and acknowledged. Yes, successfully.
yes, let me delete the scenario 0 and let me again do the same thing. Okay, now the question for you: whether this guy know about the MAC address of this PC0?
Not yet.
How you can say that confident?
Because PC1 requests the ARP to get from PC3. But
Okay.
PC3 didn't request back, isn't it? On the layer
Uh,
2.
It is not in that way. See here, whenever there is a communication is happening front and back, that means from me to you or you to me, we know about each other. Otherwise, the
Okay.
communication cannot happen
Okay.
because he initiated the request, right?
Mm.
So this piece is learning 10001 for the first time. So
Okay.
while sending, he already injected the source MAC address while initiating the ARP. So this
So
guy don't want to raise the ARP again to know about 10001. He already got that,
okay, got
right?
that from 10001.
Yeah.
Okay. So in this case,
Hmm.
you're trying to tell me if it's on dynamic host control protocol, yes?
It is not about
That
DHCP. It is
is not
completely
about
not.
DSP.
No.
It's just plain computer to computer.
Yes, yes, yes. It is
Okay.
just
So
about
the
the ARP
computer
protocol.
is a protocol that it's initiating that, but not the actual PC. Yeah.
Uh, it is a protocol actually who initiate this process, which is part of the OSI layer. You can think, right?
Yeah.
A
I'm
layer
thinking
to
of the
yeah.
I'm thinking of the OSI layer, but
Mm-hmm.
as it stands now, you've made me understand
Yeah.
the hub is not intelligent enough to learn, yes, about those things.
Yes.
The PC
Right.
will
Yeah.
be able to learn from each other
Exactly. Exactly. Yeah.
based on the app protocol, yes.
Yes.
So
Obviously.
it's similar to how Switch is learning about other devices as well. Yes.
Yes. Right.
Okay.
You're right.
All right. Okay.
Okay. What is that? Okay. So in this case, if I raise, if I send data from here to here as well as I cannot see any R. Okay. So okay, I don't want to confuse you now. So what I'll do, I'll initiate a communication again from the same sender to the same receiver. Let's see. See, only the ICMP packet is going. Why? Because already I know their IP address. Sorry,
The MAC
destination
address.
MAC address. Right.
Yes.
Okay. So let me pause and delete this scenario. And now, it's your turn. You tell me whether this PC know the MAC address of these two guys.
Not yet, because
But
that's why it's discarded. Is discarding when the packet comes there, isn't it? Because it's not his.
see, technically, they have requested the ARP. This guy is not
Said
having
I
the
don't
same
have
IP
it.
address.
Yes. He says I don't have the same IP address, so I
Yes,
can't receive the packet. Okay.
but they got the information about this guy already, right?
Already, because he sent it out, isn't it? Mm.
Yes, yes. So this
Okay.
guy will be having the MAC address of this PC
This
as well as this
PC,
PC.
yes,
But
yes.
this PC
But
MAC address will not be seen in this PC or this PC.
this PC, okay.
Let's check
Because
that whether it is the same way. But there is no ARP entries. But as of now, okay, might be it got expired.
mm,
Uh, every 500 seconds, sorry, 300 seconds, this will get expired. Okay, these ARP entries, whichever learned
okay,
dynamically. So okay,
okay.
fine. So you understood, right? When the
Yeah.
ARP initiates, what happens actually?
And then it floods it to all of them, yes?
Actually, who is flooding? Hub is flooding, right? Why?
Yes.
Okay. Let me now initiate a communication from here to here.
Mhm.
So let's see what happens. Hub is not going to see anything what you're going to send, what you're sending, from
No.
whom you're sending to whom you're sending.
So it's gonna
It's
flood to every
yeah.
PC, and then the
Except
PC.
the incoming port, it is going to flood it to all other ports.
Okay.
See here. You can see here also, right? There is a ARP
Bro,
Yes.
generated. Yeah.
Yes.
the meeting will be ending in 5 minutes. I will share the link in WhatsApp. Can you please check that?
Sure, 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 sure.
So
So
each time it sends an ARP,
yeah,
except from the main computer, it will flood it to everybody else. Yes, apart from the main one that is requesting.
I think you're confusing the ARP and the hub.
So what I'm
Basically,
saying is,
ARP has a broadcast MAC address as a destination MAC address, which is
okay,
FFF. But
FFF,
hub
okay,
job is to broadcast the packet, whatever it get from one interfaces to all multiple
to all the
interfaces.
other multiple interface. Okay,
You understood? There is no confusion, right?
okay, I get it.
Okay. Even
Uh,
switch floods, but there
yes,
are at certain conditions, certain situations.
conditions, certain
Yeah,
situations. Yeah,
yeah.
but for
I'll
a
tell
hub,
you what is that.
because the hub is not intelligent enough, that's why once
Yeah,
it gets it, it then sends to everybody else. Yes.
yeah. It is just a function of repeater.
Yeah, repeater. Yes.
Yeah, it boosts a signal from the incoming port and it will just replicate that to that outgoing port. That's it.
Outgoing ports. Okay.
Okay, let's meet in that new window, new session.
Okay.
Let
She
me.
sent me the link. Yes.
Yeah,
I hope
I
so.
have send the link in Skype for you, John.
You send in where? On Skype.
On Skype, I will send the link in Skype.
Oh, okay.
Bro, I have sent the link in
Yeah,
WhatsApp.
yeah, got it, got it.
Okay,
Okay. All
let
I'm
me
right.
access
joining
and
that.
okay, thank you.
Okay. I'll meet